Hey everyone, welcome back. Now that you have had an opportunity to review some of the properties and hopefully you had an opportunity to maybe, look at some of that textbook work on the last video lesson where it was a lot of review of the properties of logs. We're going to come back together and we're actually going to be solving equations with logs and with exponents, right? Like as we talked about, logs are exponents. Like we need one in order to work with the other. They really go hand in hand. And again, like some of this stuff you will have seen in AAF, but this was when we left. So you might have to see what you learned through the video lessons last year and on your own a little bit more. Excited. So let's get ourselves started. So using the definition to undo logs and exponents, right? So using one to work with the other, we know that, as we talked about, y equals log base b of x if and only if b to the power of y equals x, right? Like logs are exponents, they go together. Some of the things that we need to remember is that the argument is always greater than 0, not equal to 0, greater than 0. And the base, whether we're talking about a log or an exponential function, is greater than 0 and it cannot be 1. It can be anything else other than that. It's greater than 0, but it can't be equal to 1. And we're going to go ahead and solve. So we're going to have to use one in order to solve the other. So if you remember, this means that we have a base of 10. So I could rewrite this as 10 squared equals t squared. All right? Oh, maybe you know what to do. I don't know, maybe I can take the square root of both sides, and what does that give me? 10 equals t. Right? So using it to undo what's happened. Let's take a look at this one. So I want to isolate ln of x so that I can do this. I'm going to go ahead and actually add ln of x to the power of 6 equals 12 so that I don't have anything negative. I could set this up right now, but I'm going to choose to use that power rule. 6 ln of x equals 12 so that I can then divide by 6. Right? And that's going to give me ln of x equals 2. And now I can switch this to an exponential, where they can use the definition here. So e squared equals x, and now I've solved for x. Right, and you can go ahead and plug that into C. Right, if I did that, I would have 12 minus ln of e to the power of, what is that going to be? E squared to the 6. 12. Wow, I don't know why that took me a moment. Couldn't multiply 6 times 2. And then here, by definition, ln of e, well, that's going to go away, right? Or I could bring that down, and I'm going to have 12 minus 12 times ln of e. Well, ln of e is just 1, so I'm going to get 12 minus 12, which, oh, check that out as 0. Right? Check your work. Use the properties. It's great practice. And here in example 3, log base 2 of x plus log base 2 of x minus 7, right, where the whole argument, well, when we're adding logs and they have the same base, which these do, I can multiply their arguments. So that's going to give me log, base 2 of x squared minus 7x equals 3. Now let's go ahead and turn this into an exponent. So this is going to be the same thing as 2 cubed, which we know equals x squared minus 7x. Right? What power turns 2 into this? Oh, it's 3. The power that turns 2 into this is 3, if you want to read it that way. So you've got 8 equals x squared minus 7x. 0 equals x squared minus 7x minus 8. And then we can use our favorite tool, not our old, I don't know why I said that, our favorite tool, factoring. X minus 8 times x plus 1 equals 0, and I'm going to get that x equals 8 and negative 1. And let's see, do they both make sense? 8, we're good. Oh, are we? Yep. Right? What about negative 1? No, negative 1, log base 2 of negative 1, that doesn't work. That's not right. It is just 8. It is not -1, right? That's not actually a solution to this. Make sure that you're looking back where you started to see if there's any extraneous solutions. Okay, so what about this here? The ignore property. Maybe you remember that. We've talked about it a little bit. For any exponential function, if you end up with b to the u equals, right, if you get them to have the same base, or same thing with logs, right? If we had something that was log base 7 of something equals log base 7 of something else, it's not that the logs are canceling, it's that we can ignore them. Like we don't, since we've gotten them to be equivalent, we don't need to worry about them. That must mean their arguments are the same, or this must mean that their exponents are the same. So here you've got 20 times 1/2 to the power of x over 3, or 1/3 x, I guess is another way to say that, equals 5. So our goal is to solve for x. I'm going to start by dividing by 20. So I've got 1/2. I can't just do 20 times 1/2, right? Order of operations doesn't let me do that. It's not legal. Equals 5 over 20, which is what? 1/4. Okay. I think I can get this to be 1/2. Right? There might be different ways to go about this. Not there might, there are. That's mean the same thing as 1/2 squared. Oh my goodness. They have the same base, so I am going to ignore the base. I'm not getting rid of it. It's not going anywhere. I'm just able to ignore it. Since I can say, well, if their bases are the same, x over 3 has to equal to 2. And then use some nice math to get that x equals 6. And you can see, if I plug that in, I would get 6 over 3 is 2. 1/2 squared is 1/4. 20 times 1/4 is 5. Right? Maybe you went in a different direction and you said something over here and you were like, 2 to the negative x over 3 power equals 2 to the negative 2nd power. You're still going to get 6. Right? So I'm going to show you some interesting problems here. So we're going to go through 2 examples, and I think it would be really neat if you wanted to pause the video and try them before I do them and see like where you get and where you get stuck. So I'm going to start off, obviously my goal is to solve for x, and there's a lot going on here. I'm going to start by getting rid of this fraction and just multiplying by 2. E to the power of x minus 5e to the power of negative x, so that's a little confusing, equals 4. E to the power of x minus, what is this? 5 over e to the power of x equals 4. So I want to get rid of a fraction. I don't want this fraction here. This is getting in my way. So I'm going to do something to everything here, to both sides. I'm going to multiply it by e to the power of x. E to the power of x times e to the power of x. They have the same base, so let's add them. X plus x is 2x. Minus, well, that's going to cancel, right? That was my reason behind doing it. Equals 4e to the power of x. Does this kind of look familiar? If I change the e to x to just like n, maybe? I'm going to rearrange this. I'm going to put everything on one side. And maybe you see it, maybe you don't. What I'm going to go ahead and do is I'm going to use t, and I'm going to say t equals e to the power of x. And that's going to be a placeholder for the time being. So everywhere that I see e to the x, I'm just going to stick a t so that I can look at it a little bit closer. T squared minus 4t minus 5 equals 0. My goodness, you know how to do this, right? You're just factoring, right? So this is going to be the same thing as t minus 5 times t plus 1 equals 0. T has to equal to 5, and t has to equal to negative 1. Those are my answers, right? I should circle them and move on to the next problem. No, I should go back and make sure that it makes sense. Right? So let's see. Did it make sense? e to the fifth, e to the negative fifth, we're fine, right? -1, does that work? Oh wait, I'm not done. What am I doing? That's not x. Sorry. What did I do wrong? I need to go over here and say, well, e to the x has to equal to 5. ln of 5 has to equal to x. Oh, I just got one of my values for x. Okay? The other one, e to the power of x has to equal to -1. That's not possible. It has an asymptote. Not possible. Therefore, my answer here is x equals ln of 5. This is my only solution. I used substitution here to help me to see it so that I could then use factoring. But then I need to remember and write it. Oh, did you see that? I almost forgot that I have to then say, well, I have to go back and put it back in and say, well, I got t is 5, but that's really, I got to substitute that back in. And you don't want to forget it like I almost did. Can you all try this one? Okay, let's see. Let's start it the same way. Maybe? Let's start by multiplying by 2. Times 2. 2 to the power of z minus 2 to the negative z equals 10. 2 to the power of z minus 1 over 2 to the power of z equals 10. I'm going to choose to multiply through by 2 to the power of z. 2 to the power of 2z. That's fine. Minus 1 equals 10 times 2 to the power of z. So 2 to the power of 2z minus 10 times 2 to the power of z minus 1 has to equal to 0. Let's do the same thing. So I'm going to say t is 2 to the power of z. Right, so t to the power of 2, t squared, minus 10t minus 1. This doesn't factor, so what do I need to do? The quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac, 4 times 1 times -1, so what is that, 104, all over 2. So I've got 10 plus or minus the square root of 104 over 2. 104. What is that, 2 root 26, I think? 10 plus or minus 2 root 26. Yeah, over 2 is going to be, right, and 26 I don't think simplifies anymore. No, because it's 13 times 2. So 5 plus or minus root 26. So that is going to be what t is. So t, I have to then substitute that in. 5 plus or minus the square root of 26 equals 2 to the power of z. So log base 2 of 5, can you subtract the square root of 26? The square root of 26 is going to be bigger than 5, right? So I'm not going to be able to subtract it. So it's going to be 5 plus root 26 equals to z. Amazing. So that is where we're going to finish off with this. And again, make sure that you are looking at some of the homework problems and some of the practice problems, that you're getting a good review before you come to class and we look at this and talk about this and ask questions to do more practice together in class. So thanks everyone, and I will see you next time.